Hello Algebra 2A Trig. I hope you guys are enjoying the long weekend. I'm at school right now, and what I need you to do is I need you to take out the worksheet that we're working on, section 3.3 Transformation Practice, and the Transformations cheat sheet. Okay, I'm going to refer back to the Transformation cheat sheet, so please have it next to you when you're working on these two problems. Okay, I'm going to put problems 1 and 2 in this video, and your homework is going to be to work on 3, 4, 5, and 6. Okay, and I would like you to follow the exact same process that I'm working on when I do problems 1 and 2. The reason being is because you're going to start getting comfortable with the different parent functions. So if you know your 6 parent functions, you understand the transformations, each problem is going to be very similar, if not the same process. Okay, so please follow along. If you notice on problem 1, we are looking at the parent function of the square function. Okay, so I'm going to go to a new page here and I'm going to show you what that square function looks like, because I'm going to find a few specific points that I know are for sure on the square function. If I take negative 2 and I square it, I get 4. Negative 1 squared gets 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So here's my parent function for the square function. Okay, and this is important because I have 5 points on here that I'm going to use for my transformation. I have 1 point that's negative 2, 4. I have 1 point that's negative 1, 1. Another one, 0, 0. 1, comma 1, and 2, comma 4. So these are the points that I'm going to put in my XY table. So let's go back to this transformation problem number 1. Okay, so the first thing I see here, my parent function. You don't have to write this if you don't want to, but this is the one we're going to be using for this problem, is the square function. Okay, and now what I'm going to do is I'm going to list the transformations that I see. Okay, so first, if you look at your transformations cheat sheet, it says the general order on the bottom. It says flip first, so that's if we're doing any reflections over the x-axis or y-axis. Then it says take your x value transformations and then your y value transformations. So that's the process we're going to do. Okay, so I'm going to write out my transformations here. First, I see that negative sign outside of the parentheses. So that means a reflection over the x-axis. Okay. Next, I see that I'm doing my x transformation, so it's moving to the right 4 because it's a negative 4 inside that parenthesis. So right 4. And lastly, I see the plus 1 on the outside, so that means I'm going up 1 unit. Okay, so these are my three transformations, and this is the order I'm going to go in. Okay, so next I'm going to create an XY table with the points that I know are on the original parent function. Okay, and I just showed that on the last page. So I have negative 2, negative 1, 0, 1, 2. And that comes out to be 4, 1, 0, 1, 4. So now I have my original points on my original parent function. And I'm going to show you what I do to these points based off the transformations. So the first one is reflection over the x-axis. So if you look at your transformation sheet, you find on the bottom left, where it says y equals negative f of x, that's the transformation we see. That's a reflection over the x-axis. So to do that, you have to make all the y values negative. So in my table, I'm going to make each one of these y values negative. 0 is still 0, 1 is negative 1, 4 is negative 4. Okay, and then it says write 4 units. So I'm going to look at my cheat sheet, and I see whenever it says y equals f of x minus h, that's going right h units. I need to add the h to the x values. So this one in this case is 4. So I'm going to add 4 to each one of my x values. So that's going to give me 2 here. Okay, so I get 2, I get 3, I get 4, 5, and 6. And last it says up 1 unit. And if you look at your transformation cheat sheet, y equals f of x plus k, I need to add k to the y values. So I need to add 1 to all the y values. So I have negative 3, 0, 1, 0, negative 3. And now I have my new set of x, y, a table that gives me 5 different points to plot in my new graph. So I'm going to plot 2, negative 3. Right here, 3, 0. 4, positive 1. Through 5, 0. And then 6, negative 3. And here is my new graph after my 3 transformations. Okay? Now we're going to follow the exact same step. process for number 2. Okay, it says graph the function by listing the transformations in order and applying the transformations to an xy table. Good. So the first thing I need to check out is my parent function. My parent function in this case is my square roots. Okay, so what I'm going to do over here is go to the next page and show you a few points that are on my square root function. So here's my square root function. Square root of 0 is 0. So I have one point is 0, 0. The square root of 1 is 1. So another point is 1, comma 1. Now I'm going to go to the next perfect square, which is 4, and the square root of 4 is 2. So these are 3 points on my square root function. This is the parent function here. So now I'm going to use those 3 points in my xy table. Okay, so now I have my parent function. I have a few points here. Let's put those in our xy table. I had 0, 0, 1, 1, and 4, comma 2. And now I'm going to list the transformations in order. Okay, there's a 2 on the outside, which means it's a vertical stretch. And you'll see what that looks like. My second transformation is the x transformation. It is x plus 1, so that means I'm moving to the left 1 because it's opposite. And lastly, I have a negative 3 on the outside, so that means I'm going down 3 units. Okay, so let's apply these transformations to our xy table. Vertical stretch first. If you go down to 1, 2, 3, 4, 5, 6, the 6th row, it says y equals a times f of x. So that coefficient is on the outside of the function. If a is greater than 1, it's a vertical stretch. In this case, it is 2. So what it says in the last column says, how do you do that? You got to multiply the y values by that a. So it's a vertical stretch of 2, so I'm going to multiply all my y values by 2. And you'll see 0 is still 0. 1 times 2 is 2. 2 is 4. Okay, so I've applied my vertical stretch. And then I'm going to the left 1. So that means I need to subtract h from the x value. So I'm going to subtract 1. So I get negative 1. I get 0. And I get 3. Okay, so now I have my new x values. And last but not least, I'm going down 3. So I need to subtract 3 from my y values. So I get negative 3. I get negative 1. And I get positive 1. These are my new x, y points. Negative 1, negative 3, right around here. 0, negative 1, right here. And 1, 2, 3, up 1, right here. So if you look at my new parent function, you'll see that I took my original parent function, I moved to the left 1, I moved down 3, and I had a vertical stretch of 2. And you can see the complete difference, because if I refer back to the parent function, here's the original. Look at that, it is vertically stretched out, and it is moved to the left 1 and down 3. Okay, so please follow this exact same procedure for the next 4. And when you come back in on Monday, we'll talk about these last 4, see how we did, and we will move on to section 3.4. Enjoy the long weekend, guys.